Now we apply technology acceptance theories to new technologies such as autonomous vehicles and chatbots. Autonomous vehicles are intelligent vehicles equipped with communication networks, sensors, IoT, artificial intelligence, devices that can be remotely monitored, accessed and controlled, and which provide services that respond to the driver's needs, which automates driving systems. These smart devices sense the surroundings and engage in real-time data collection, interactions and feedback analysis via AI to propose suitable solutions for driver comfort and security. The main goal is, like for smart homes, to increase consumers' road safety and reduce accidents, because 95% of accidents are caused by human error, according to the study of the Human Parliament. So autonomous vehicles should increase quality of life, safety, automation of driver labor, and should increase energy efficiency. So to give you some information about the market evolution of autonomous vehicles, according to the European Road Transport Research Advisory Council, AI-powered AVs will be available on the European market from 2020. There are different levels, which we'll see in some instance. By 2023, worldwide sales of AVs driving without human supervision will reach almost 1 million of units. AI-based AVs represent a potential market of 55 million vehicles sold within the next 20 years. The most part will be sold in Asia, because Asian countries will have the first place in terms of AV sales by 2040. And the technologies used are more and more accessible with LiDAR, sensor fusion, artificial intelligence, 5G, and the regulations are becoming more and more flexible.
Like for the smart home, we have the same arguments. Consumers are reluctant to give over control of technologies to AI or to robot. As if you're able to trust or to give control to a smart watch in order to observe if we have done enough steps in our life today, or if you have done enough sports, or if you have not eaten too much calories. So these are actually low involving tasks. We are highly reluctant to give over the control to technologies which concern our safety. That's why, again, very important to understand these main barriers, which are, again, like for the smart home, privacy concerns, technology fear, the confusion of autonomous cars in unexpected situations, loss of control, because the level 5 cars won't even have anymore a steer wheel. So if we want to take the control, it becomes difficult. That is why it is important to understand to which extent customers are ready and how and why users accept or reject AI-based AVs. The contribution to understand better the factors that influence positively and negatively the acceptance of autonomous vehicles. We contribute to the technology acceptance theories by integrating new variables, and as you can see, we have also introduced hedonism, but also effort expectancy, social recognition, well-being, and technology trust in order to understand also the consumer resistance. And final study about technology acceptance was about chatbots. What is a chatbot? It's a service robot that are conversational agents that interact with users in a strictly limited domain or on a certain topic with natural language synthesis, generally deployed on the internet for the purpose of seeking information and task-oriented dialogues for a broad range of applications.
Today, chatbots are generally deployed on the internet for the purpose of seeking information, site guidance, and frequently asked questions. But in the future, chatbots will do high value-added activities and applications, such as being a beauty agent or even mHealth agents supporting doctors. In this regard, chatbots may differ in the level of intelligence. 4 different types of chatbots and intelligences exist that depend on the nature of service: mechanical, analytical, intuitive, empathetic. Mechanical intelligence or chatbots is the most basic level and concerns the ability to automatically perform repetitive tasks that do not require advanced training. In this case, a chatbot is rule-based and it does not understand the external environment. Analytic intelligence refers to the ability to process information, to problem solving and learn from it. Machine learning and data analytics techniques allow the technology to learn from data and find insights without being programmed, allowing mass personalization based on big data. Mechanical and analytical intelligences are still considered as weak AI because they simulate intelligence but do not have intuition. But they are used to analyze big data and to give recommendations with recommender systems. At the highest level of complexity, there are intuitive intelligence, which refers to the ability of the AI chatbot to think creatively and adjust effectively to novel situations. And finally, empathetic intelligence, which is the ability to recognize and understand other people's emotions, to affect them and to respond appropriately. These two intelligences represent the most advanced generations of AI and chatbots, but they are still far from reality. In this regards, chatbots can be distinguished from humans in that service employees have their own limited capabilities, perceptions, and weaknesses, heterogeneity across individuals. Human employees need to have a deep understanding of the customers and service processes to deliver heterogeneous, individualized services, and to achieve this, learning is needed. Furthermore, connecting employees to customer relationship management systems requires time and efforts. Service employees represent high costs through training, but then can be a source of competitive advantage. Differentiation in service can be based on better hiring, selection, training, motivation, and organization of service employees. In contrast, chatbots acquire knowledge quickly and system-wide through CRM systems as well as AI to determine optimal solutions. Furthermore, chatbots are free from human error and fatigue, do not show heterogeneity, and automatically providing homogeneous services in a highly reliable manner. Furthermore, they do not feel and express real emotions. So they can be perfectly used in the service quality improvement process to improve service quality with self-qual. In fact, the majority of chatbots are designed at the mechanical and analytical level today. On the one hand, they offer the advantage of being cost and time effective, always available and extremely consistent. But on the other hand, they may fail to satisfy consumers and have a low potential of competitive advantage. In fact, the pre-programmed scripts may pose a risk of not properly responding to the user's requests, leading to customer frustration and dissatisfaction. For this reason, it is important to consider the level of efficiency and competences of a chatbot to meet customers' expectations. Information provision, processing, bookings, and payments are considered the most appropriate areas of service robots. But in the future, chatbots will be intuitive and empathetic. Possible applications are beauty agents or even mHealth agents supporting doctors in hospitals. This is commonly called mHealth.
Virtual doctors or virtual chatbots taking over the role of a doctor. You get advice from the chatbot about your treatment or about your disease. This is also called mobile health market. Is a highly dynamic market, which will also double in the next 10 years. Our projects, I think all major hospitals in US, Europe, are working on this, what is called e-health or mobile health. Even until 2020, 85% of all customer interactions and customer service will be handled without a human agent. And as of 2017, over 100,000 chatbots have been created. So 3 years ago. So I think it should be at least 1 million of chatbots working today. And almost all organizations plan to outsource and to automatize customer dialogue to chatbots. So you can see it is like smart homes and like autonomous cars, a highly important evolving market. And again, we have the same problem. So users are still reluctant. Above all, if you look to the mobile health sector, they're skeptical about the quality of the service production, considering that AI is rapidly reshaping customer service. There is thus the need to comprehend which is the most effective and beneficial way to implement these technologies in order to guarantee higher perceived service quality and a positive customer experience, because chatbots aim at enhancing customer experience. So it's important to understand the perception of this new form of technology mediated communications. And our research for the chatbot study, which is published in Journal of Service Research Management, to understand the perception towards AI-based chatbot service agents. Investigations in marketing are missing about service frontline experiences with highly automated social presence, thus chatbot without human social presence, like the case of chatbots or service robots. So there's few research how humans actually react towards chatbots. The investigation about the perception of service quality and acceptance after a real experience with an existing chatbot is another contribution. So we worked with a real chatbot and had a real experience, field experience with a real chatbot. This is another contribution of our research. We integrated and enhanced and combined two theories. First of all, the theory about service quality, ServQual, and combined it with the technology acceptance theory. So we have two established theories which are combined in order to test them in the new emerging context of AI-based service agents and chatbots. And we studied the relationship between usability also, so ergonomics, ease of use, but also aesthetics, and its effects on intention to reuse the chatbot. And thus we created a link between different domains of research, IS literature, marketing, service literature, user experience literature, opening further research in related fields. So I will show you now our different models. Again, we use established theory, the UT and UT, with performance expectancy, which is defined as the perception that the use of the technology will enhance the user performance. Effort expectancy, which is the perception that the use of the technology is simple and effortless. In the TAM model, this corresponds to perceived usefulness and perceived ease of use, which both should influence behavioral acceptance and intention to use. And we introduced different variables which appeared relevant in our former studies about smart connect objects and IoT, which is also relevant in the literature. That is well-being, which we define as the personal state of mind linked to different factors: psychological health, social, economical, pleasure, harmony, happiness, and medical conditions. And we naturally expect that the higher the well-being given by the technology, the higher should be the intention to adopt. This is the same for social value.
Social value is the degree to which the use of the technology will enhance the user's social status within her or his social group.
Social value should positively influence intention to adopt, because they give us value within the group, and the more we have the value in the group, the higher our perceived benefits or performance expectancy, and there should be thus a positive link on intention to use. Technology trust, which is the personal psychological state of mind that the technology does not bring us vulnerability, and that this technology won't betray us or won't fail us. And privacy concerns, which are beliefs about the data flow collection done by the firm and strongly related to trust. And so the higher the trust, the higher the intention to use, and the higher the privacy concerns, the lower the trust, which would subsequently decrease the intention to use the technology. And we introduce a new concept, technology fear, which refers to the user's perception of the limited ability to manage, control, and perform securely a technology. It refers to the perceived risk of the technology itself and how it might cause intimidation, errors, accident that could harm the user's health. So the higher the technology fear, the lower the trust, and the lower the adoption probability. And technology security refers to the perceived safety of the technology itself and how it reduces human errors and accidents that can harm users' health. For all the studies, we used established scales. So we have different studies. The scales all worked well according to the different reliability and validity. We have different samples for an autonomous vehicle where we had 207 respondents in France. Almost half of them are men and women. The average age is quite younger because it was a student sample. And we showed a video about a level 5 car, so a fully autonomous car, before the survey. And the study about the chatbots was also done in France with Flybot, which is a real existing chatbot, where we asked the respondents to search a flight before answering to our survey, so a flight from Toulouse to New York. And then we asked them how it worked. And our sample, again, it was a student sample, more highly woman-oriented, 73% women. The average age is quite young. It's also the main limit of these two studies. Let's have a look on our conceptual model. So the study is about autonomous cars. Here's our model. So you can see here again, effort expectancy, social recognition, and perceived hedonism, which have positive impact on performance expectancy and well-being. We see again, the privacy concerns and perceived technology security have respectively a negative and positive impact on trust, which subsequently should positively impact behavioral intention to use. It is the same for well-being and performance expectancy, which both should positively impact behavioral intention to use. And you have here the user innovativeness, so which the higher the user innovativeness, the higher should be the links between well-being and performance expectancy on behavioral intention of use. Here are the results. Again, in line with literature, we confirm the links coming from the AUT literature. So effort expectancy has a positive link on performance expectancy, and performance expectancy has a positive link on behavioral intention of use of autonomous cars. The easier it is to use, the more it brings benefits, and the higher will be also the intention to use it. We see also here the highly significant link between well-being and behavioral intention of use, in line with our hypothesis and in line with literature. We see that social recognition is not significant. There do not seem to be valorizations through social recognition, but social recognition increases well-being. So that's an important point. We also see that perceived hedonism increases also performance expectancy, namely the benefits perceived. Perceived hedonism increases well-being, so highly positive and significant. Trust increases well-being, in line with literature. Trust increases behavioral intention to use. And we see also in line privacy concerns decrease trust, and technology security increases. We confirm, most of all our links are also confirmed and shown in the literature. And finally, you will see here the conceptual model of acceptance of chatbots. This article is published in Journal of Service Management Research. So you see here the self-quality dimensions. The service quality is actually evaluated through material element, tangibles. So for example, physical uniforms of service providers or the equipment of service providers. The more attractive, the more the design is nice, the more these tangibles are perceived as positive. So this is established in literature. The tangibles have a positive impact on service quality. The competence is another important factor in the service quality model, which is based on the capacity of the service provider, in this case the chatbot, to bring and to give and adequate information. Reliability, we find is that a service provider will be reliable and produce a reliable service. Responsiveness is the speed of answer. Empathy is the personal care and individualization that the service provider brings to the customer. And credibility, what the service provider is doing, is perceived as credible and believable. And so we have hypothesized that these factors should have a positive impact on the traditional variables to the TAM model, namely perceived usefulness. We see that tangibles should have a positive impact also on perceived use. And we have the established link between perceived use on perceived usefulness and subsequently on intention to reuse the chatbot. And we see here actually also empathy and credibility should positively impact trust, which subsequently should impact intention to reuse. And then, as I said, we have tested it with a real chatbot. Here are the results. In line with literature, tangibility influences positively perceived usefulness, but also perceived ease of use. We don't confirm the impact of competence on perceived usefulness, probably because we consider that a chatbot should be competent, simply not conceivable that a chatbot is not competent. We see that the reliability is also highly significant and highly positive. We don't confirm the links between responsiveness and empathy on perceived usefulness and empathy on trust. But we confirm the positive link between credibility and trust, which is highly significant, highly positive. We don't confirm, this time in contrast to literature, the link between perceived ease of use and perceived usefulness, which is the link actually from the basic Davis TAM model. We confirm a link between perceived usefulness on intention to reuse the chatbot, but reject the links between perceived ease of use on intention to reuse and trust on intention to reuse.